Hello everyone, and welcome to the Mathematecher channel. So in today's video, we have a Diophantine equation, which is specifically a homogeneous Diophantine equation of the second degree of three variables. We would like to prove that this equation, which is x² plus y² equals 3 times z², has no other solution than the trivial solution, 0, 0, and 0. So let's see the proof. If we note d as the greatest common divisor of the variables x, y, and z, then the ratios x over d and y over d and z over d would be coprime numbers. We will mark this as assertion 1. So the equation x² plus y² equals 3 times z² implies that x over d all square plus y over d all square equals 3 times z over d all square. Now, if we calculate the congruence of the squares of x over d and y over d and z over d modulo 4, we will find that, whatever the values of x, y, z, and d, the squares of those ratios are congruent to either 0 or 1 modulo 4. And this means that on one hand, the sum x over d all square plus y over d all square is congruent to either 0, 1, or 2 modulo 4. And on the other hand, 3 times z over d all square is congruent to either 0 or 3 modulo 4. So the only case for which the equation x over d all square plus y over d all square equals 3 times z over d all square can be satisfied is when the squares of the ratios x over d and y over d and z over d are congruent to 0 modulo 4, which mean that these squares are all even. Let's mark this as assertion 2. So the ratios x over d and y over d and z over d would be even too. And as assertion 1 states that these ratios are coprime, then if they're not all equal to 0, the conjunction between assertions 1 and 2 represents a contradiction. We therefore deduce that, except for the trivial solution 0, 0, and 0, our Diophantine equation x² plus y² equals 3 times z² has no integer solutions. Thank you for watching. We hope this was clearly explained. Like the video and subscribe to the channel if you're new to it. And until the next time, we wish you the best.